Today, we're diving into one of the most powerful shortcuts in all of artificial intelligence. It's a technique called fine-tuning, and it's a real game changer. When you think about creating an AI model from scratch, it really is like trying to solve this gigantic, incredibly complex puzzle. There are just countless pieces, and you have to figure out how every single one of them fits together perfectly. It is a huge, huge task. And that's the promise of this whole technique. Imagine someone just hands you a puzzle that's almost finished. All you have to do is pop in the last few pieces. Well, that's pretty much the core idea behind the AI shortcut we're talking about today.
But to really get why this shortcut is so amazing, we first have to understand the mountain you'd have to climb otherwise. So, let's take a look at the massive challenge of building an AI model from the ground up.
Building a model from zero is just this huge trial and error process. You're faced with dozens of really critical questions. How many layers does it need? These are kind of like the thinking levels of the AI's brain. What type of layers should they be? How many nodes, the artificial neurons, should go in each one? And that's all before you even get to tweaking all the abstract settings. If you get it wrong, you pretty much have to start over, which can burn an unbelievable amount of time and computing power. So how do we skip all that pain? This is where our clever shortcut comes in, fine-tuning. Let's break down exactly what this means. Okay, so fine-tuning is built on this really simple but powerful concept called transfer learning. The idea is just taking knowledge from one task and applying it to a new but related one. You're not reinventing the wheel. You're just putting that wheel on a different car. And fine-tuning is just a specific, really practical way of using transfer learning. We take a model that someone else has already trained, we call it a pre-trained model, and we just tweak it a little bit to fit our new task. It's an incredibly efficient way to work.
To make this crystal clear, let's use a simple analogy. How would you teach an AI that already knows all about cars to suddenly understand trucks?
So picture this. We have a model that's an expert at identifying cars in pictures. It's already seen thousands and thousands of them. Now our new goal is to make it recognize trucks. What knowledge can we actually carry over from the first task?
Well, it turns out a lot of the knowledge is transferable. The model already understands general things like edges, shapes, headlights, and wheels. That's the hard part. The only new piece of the puzzle it really needs to learn is that one specific feature that defines a truck. It's open bed. We don't need to reteach it what a wheel is. This all sounds great in theory, but how does it actually work in practice? Let's break down this step-by-step process.
It's actually a pretty straightforward process. First, you import that pre-trained model, our car expert. Second, you modify the very end of it. The last layer of the old model was designed to say car. We just swap that out for a new layer designed to say truck. Third, and this is the most important part, you freeze all those original layers. And finally, you train the model with your new trick data, but you're only training the new layers you just added.
That freezing step is the magic key here. By locking the original layers, we protect all the valuable knowledge the model already has. This stops the new training process from accidentally making the model forget what a wheel or a windshield looks like. We're essentially just locking in all that general, foundational knowledge.
So let's zoom out for a second and look at why this technique is so important for the entire field of AI. This isn't just some neat trick. It is an absolute game changer.
Ultimately, fine-tuning means you don't have to spend weeks or months and massive amounts of energy and computer resources reinventing the wheel. You get to stand on the shoulders of giants, leveraging the incredible work already done by major research labs. This makes powerful AI accessible to more people than ever before, and it dramatically accelerates the pace of innovation.
So, it leaves us with a really fascinating question. This ability to transfer knowledge is fundamentally how we humans learn. And now that we've given this power to our machines, letting them adapt and build on existing knowledge so efficiently, what incredible problems are they going to be able to solve for us next?